That was some nice music. Such a lovely sound. There are so many sounds all around me. Sound, it's really an amazing thing, and such an important part of our lives. I wonder, how is a sound made? Almost everything I can think of produces some kind of sound. There is music. There is talking.
That's right. What else?
And sounds of animals and machines. Loud and soft sounds. High and low sounds. Lovely sounds and not so lovely sounds. I wonder, what makes these sounds so different from each other? And where does it all come from to begin with? How can I find out?
Hi, Cindy.
Hello. Excuse me, but who are you?
My name is Sounderella. I am the Sound Fairy. I see you have some questions on your mind. I have come to help you out.
Yes, but how do you know that?
Let's just say I was passing by and I heard you talking to yourself, asking all these interesting questions.
Then you already know what I'm wondering about?
Oh, yes. You want to know about sound, right?
Yes. Can you tell me the answers to all these questions?
I surely can. But before I answer your questions, let me ask you one. Do you realize the importance of sound in our day-to-day lives?
Yes, I was just thinking about that.
Yes, I heard you. You were right. Sound is everywhere and very important. We need it to talk
That's
to
right.
and understand
else?
other people, to pick up clues like alarms and what they mean to you. Like a phone ringing tells you someone's calling. A fire alarm warns you about a fire. From people talking to machines beeping and sounds in nature to the music you listen to, they're all just different kinds of sounds.
I see. So many sounds.
But Cindy, do you know all sounds have one thing in common? They are all a form of energy, just like light and heat. And all sounds are produced by vibrations.
Vibrations?
Yes, vibrations. That means back and forth movement of something. It could be anything. A guitar string. A drum cover. Even air particles. In fact, most of the sounds you hear are only possible because of the vibrations of air particles. Air is actually made up of a large number of tiny particles. They are too small for us to see, but they are everywhere around you.
So how do these air particles make sound?
Instead of telling you, better let me show you. Watch carefully now. When I pluck a string of the guitar, the string moves back and forth. Here, let me show you again. Did you see that? This back and forth motion of the string is an example of a vibration. When the string moves, it pushes the air particles around it in the direction of its motion. So, the vibrating string makes the air particles vibrate. In the same way, when we strike the membrane of a drum, the membrane vibrates and makes the air particles above and below it vibrate. When we blow air into a trumpet, the air column inside it is vibrating.
This is so cool. So many sounds explained by one single idea.
Yes, Cindy, you got it. Every sound is produced by the vibration of some or the other object. Even when we speak, it is our vocal cords vibrating, which is actually producing the sound. I hope you understand that much.
Yes, Sounderella, I feel quite confident about that now.
Cindy, there are very many different kinds of sound. You just heard a guitar. Now I want to show you something else. Look. Watch closely. Look for the vibrations and hear the sound. I am sure you noticed it was a different sound this time. Do you want to know what makes it different? It is the pitch of the sounds made by a guitar and a drum that makes them sound so different.
Pitch? What is that?
Pitch tells us how high or low a sound is, or how sharp or flat a sound is. It depends on how fast or slow the vibrations are. Low sounds come from slow vibrations, and high sounds from fast vibrations. So, pitch is a property of sound. Let me give you some examples of high-pitched sounds. The sound of a violin. Or a siren. Or a whistle. Low-pitched sounds are drum beats or a lion's roar or a human heartbeat.
So, slow vibrations mean low pitch and fast vibrations mean high pitch. I got that.
Very good, Cindy. Now, there is something else that makes a lot of difference in the sounds we hear. I am talking about the volume of a sound. I think you already know it a little, but let me explain. When someone shouts, the sound has a high volume. And when someone whispers, it has a low volume. So you can tell apart the loud and soft sounds by their volume. because volume is also a property of sound, like pitch. There are many loud and soft sounds around us. A car's honking. Banging of a hammer. An aeroplane taking off are all loud sounds. Actually, that's how loudspeakers get their name, because they always speak so loudly. On the other hand, a clock ticking. Human heartbeat. And wind blowing are soft sounds.
There is something I'm still not clear about. Pitch makes sounds high and low, and volume makes them loud and soft. So, does that mean high-pitched sounds can be soft too? And can low-pitched sounds be loud?
I am so glad you asked that. You're a smart kid. Yes, pitch and volume of a sound are two very different things. A high-pitched sound can be both soft and loud, and same goes for a low-pitched sound. Just imagine the volume knob of your music speakers playing a violin sound. It can play it at both high and low volumes. In the same way, you can play a drum sound at both high and low volume. I hope that cleared your doubt.
Oh, now I understand that completely. Wow, I have come to know so many new things today.
That's wonderful. Cindy, how would you like to tell me what you learned in your own words? I want to know how much help I was to you today.
You helped me a lot, dear Sounderella. I will remember this for a long time. Hey, that puppy's barking is a low pitch and a high volume sound, right?
You're right.
So, to put it in my own words, I learned today that sound is a form of energy. It is always produced by vibrations of an object. Sound has two important properties, pitch and volume. Pitch tells us how sharp or flat a sound is. Volume tells us how loud or soft a sound is. Both high-pitch and low-pitch sounds can be soft as well as loud because pitch and volume are two different properties of sound.
Transmission of sound. Every sound is produced by a vibration. Vibration is the back and forth movement of an object. As you speak, vibrations are produced by the vocal cords in the throat. You can hear only when the sound energy reaches your ears. But how does sound energy travel? Wonder how that works? Come, let's go across to Dr. Zook. Sound energy travels in the form of sound waves. There are mainly two types of waves, transverse wave and longitudinal wave. Let us see how waves travel. We can use a slinky spring to observe both types of waves. Emily is holding one side of the slinky, while Dr. Zook is holding the other end. With a quick upward flick of the wrist, Dr. Zook has sent energy traveling through the slinky. Notice how the slinky moves? This is a transverse wave. In a transverse wave, the particles vibrate at a right angle to the direction of the wave. The wave traveled from Dr. Zook to Emily and back. Now let's see what a longitudinal wave looks like. Emily is holding one end of the slinky, while Dr. Zook is pulling its other end towards himself and then pushing it towards Emily. Watch closely and you will notice that some of the coils crowd close together and then slowly move farther apart. This is because the vibrations are parallel to the direction of the wave. If the wave moves from right to left, then the particles also vibrate from right to left. This is a longitudinal wave. Sound waves are longitudinal waves. These waves travel at different speeds in different mediums. The medium could be a solid, liquid, or gas. Now let's see how this works. In a solid, the particles are very close together. Sound energy moves as one particle hits the other particle. With the particles being so close together, sound travels quickest through a solid. If we look at particles in a liquid, they appear to be slightly further apart when compared to solid. Thus, sound energy takes a little longer to travel through a liquid. Look at the particles of gas. They are spread out, and hence, sound waves travel most slowly through them. Now we know how sound travels in different media. The vibration of particles produces waves. Wavelength is the distance between two consecutive compressions or rarefactions. The number of waves passing through a point in a second is called frequency, and it is measured in hertz. Sound waves travel in all directions.
Emily?
Sound gets reflected. That is, it bounces back on hitting a solid surface. Bouncing back of sound is called echo. Bouncing back of sound is purposefully used in detecting depth of seabeds. That's amazing, isn't it? Summary: every sound is produced by a vibration. Vibrations are produced by our vocal cords when we speak. There are two types of waves, transverse wave and longitudinal wave. In a transverse wave, the particles vibrate at a right angle to the direction of the wave. In a longitudinal wave, vibrations are parallel to the direction of the wave. Sound waves are longitudinal waves. Sound travels quickest through a solid. Wavelength is the distance between two consecutive compressions or rarefactions. The number of waves passing through a point in a second is called frequency, and it is measured in hertz. Bouncing back of sound is called echo.